Hello and welcome to 1.3 Polynomials and Factoring. So polynomial, let's talk about what those are first. Polynomials, first of all, in terms of polynomials, some terms we have to define. Constant is a number such as 5, 27, -3, anything like that would be a constant. It's a fixed number, it's not going to change. A variable is a letter or symbol that represents a value, like x, theta, to get into angles. A term is a constant variable or product of a constant and variable, and the degree of a term is the sum of the exponents on the variables of the term. So if you had 2x cubed y to the 5th power, the degree is 8. Monomial is a single term, a binomial is a sum or difference of two terms, and a trinomial is a sum or difference of 3 terms. And a polynomial is a sum or difference of many terms. I mean, technically, monomials, binomials, trinomials are all polynomials, but it could have 4 terms, 5 terms, or however many terms you wanted to have. And the degree of a polynomial is the largest of the degrees of the individual terms. So polynomials of a single variable. That's the most common what we deal with here. A polynomial in the variable x of degree n can be written in the form a sub n, x to the n, a sub n minus 1, x to the n minus 1, plus ... a sub 1, x, a sub 0. Now the a's are numbers. These are just numbers. You're not going to see two variables together. The variable is the x. The reason it says a sub n, that means it's that coefficient, the coefficient that goes with x to the n power. A sub n minus 1 is that coefficient that goes with x to the n minus 1 power, and so on. So this form is called descending order because the powers are going down as we go along. X to the n, x to the n minus 1, until they get down to x, and then a constant, if constant is not 0. So they're descending in power as you go from left to right. So leading coefficient of this polynomial is called a sub n. It's the coefficient of the biggest power term. And you can add two polynomials by combining like terms. So let's add or subtract the polynomials as we have indicated here. We have as 4x cubed plus negative 2x cubed. So I'm putting the x cubed parts together. Those are like terms. Minus 9x squared. Then we have a plus 1 plus a negative 8. So those are also like terms. So 4x cubed plus negative 2x cubed is 2x cubed minus 9x squared minus 7. It's combining like terms. There are no other x squared terms, so that one didn't change. Are there any questions about that? Okay. Well, the next one is a difference of two polynomials. All right. Kaylee, any questions about the first part there? So, okay, for this next one, good. Next one, we have this subtraction here, so I'm going to distribute that to all the terms. So it's going to be a minus 4 plus 6x plus 3x squared. Now we can combine like terms. 5x squared plus 3x squared. Those are like terms. We have a minus 6x plus 6x. And we have a plus 2 minus 4. So it's 8x squared minus 2. Hopefully this is review for everyone. Okay. So any questions before we go to the next page? Okay. Now, multiplying two polynomials. Most people remember the FOIL thing. First, outside, inside, last. So if you have a binomial times a binomial, you follow this format. First, outside, inside, last. So the first ones here be the x squared and the x squared. Outside, x squared and the y. So plus x squared times y. Then we have a minus, so inside, minus 2y times x squared. So minus 2y times x squared. Then minus 2y times y, minus 2y times y. It'd be x to the fourth plus x squared y minus 2x squared y minus 2y squared. And I want to point out what I did here is I had negative 2y times x. I wrote it as minus 2x squared y because we typically write our terms alphabetically. X comes first, so it's x squared and then the y. That's a common thing. So the only like terms we have here are the x squared y and the minus 2x squared y. It's x to the fourth minus x squared y minus 2y squared. So that was foiling. And that works. We have two terms, a binomial times a binomial, two terms times two terms. Let's go ahead and try the next one. This we couldn't FOIL because we have three terms times two, but it really isn't any different. I mean, in essence, it's the same because we are just distributing every term times every term. So like this x from the first polynomial times our x minus y, x plus y times x minus y, and y. Oh, forgot my plus there. Plus y times x minus y. So it's x squared minus xy plus x squared y minus xy squared plus xy minus y squared. See, y times x is the xy. Let's see, which of these are like terms? This minus xy and the plus xy are like terms. I think that's it. So we have an x squared y and then an xy squared, so those are different. There we go. So any questions about these two? Okay. And if you have a microphone, feel free to talk. You don't have to type it every time. You can say, oh, no questions good here. Or, wait a second, I had a question about that. What happened to that x squared? Okay, special products formulas. This is the sum and difference one. A minus b times a plus b is a squared minus b squared. A plus b quantity squared is a squared plus 2ab plus b squared. A minus b quantity squared minus 2ab plus b squared. A plus b, the quantity cubed, is a cubed plus 3a squared b plus 3ab squared plus b cubed. And a minus, scroll this down a little bit, a minus b quantity cubed is a cubed minus 3ab squared plus 3ab squared plus b cubed. So this is the products. And there is a difference when we see the factoring. We typically will see the factoring of a cubed plus b cubed or a cubed minus b cubed. So this part, the last two here really are different than what you're going to see when we get to the factoring part. You probably haven't seen the a plus b cubed, a plus b quantity cubed, a minus b that quantity cubed. You may not have seen that before, but here it is for the first time. If it is your first time seeing that. Now I will say too, if you remember in 1.2 of the lesson, I didn't go through and work on every time when I had, for example, we're doing a rationalizing the denominator. And when I had like square root of 2 plus 5, or square root of 2 minus square root of 5 times square root of 2 plus square root of 5, that's what it was. I just went with what this pattern is. I'm not going to go through and work it out every time. at this point. And in 096 I would, but now it's like we need to have that down so we don't have to reinvent the wheel every time. Okay, moving on. Page 3, common factoring methods. So factoring is the reversing the process of multiplication in order to find two or more expressions whose product is the original expression. And that works for just single terms versus binomials and so on. Factorable is a polynomial with integer coefficients. It can be written as a product of two or more polynomials, all of which have integer coefficients. So the key to it is the polynomial has integer coefficients, positive or negative whole numbers. And then the factors have integer coefficients. If the coefficients are irrational, then it's not factorable. And I would argue, too, though, they could be rational. I mean, maybe they're fraction coefficients. That would be okay, in my opinion. But prime or irreducible is a polynomial that cannot be factored. And completely factored means to write a polynomial as a product of prime polynomials. Greatest common factor method. Factoring out those factors common to all the terms in the expression. This is the least complex of the factoring methods to apply. And the greatest common factor among all terms is a product of all the factors common to each term. So here we have x cubed minus y, the quantity squared, then just an x cubed minus y. So what's a repeated factor here? What's our GCF? What do you think?
Is it the x cubed minus y?
Very good. Everyone got that right. Good. It is x cubed minus y. So it's in essence, we have x cubed minus y squared minus x cubed minus y, right? And we're going to factor that out. So that means we're going to be pulling x cubed minus y out, which essentially means to divide it out of each term. So we're dividing out of each term that's pulling out front. So if I multiply back through, it would be what we originally had. So it's x cubed minus y times x cubed minus y squared divided by x cubed minus y is just x cubed minus y. X cubed minus y over x cubed minus y is just 1. So what's left? From the first part, x cubed minus y, and from the second part, 1. That's how that would factor out. I realize that's probably more most of anything we did for greatest common factoring in 096. This next one's more like what you might have seen before. What's our greatest common factor here? We have 27x to the 7y plus 9x to the 6th y minus 9x to the 4th yz. So first think, what is the common factor between 27, 9, and 9?
9.
9, good. And we have x to the 7th, x to the 6th, x to the 4th. So we have to take the smallest of those. What's it going to be?
X to the 4th. Good.
And then we have a y, a y, and a y. So there's a y. And there's only a z is only in one of them, so we can't pull that out. And Joy, I saw you got that down there too. That's great. So we're going to have a 9x to the 4th y times, we have 27x to the 7th y divided by 9x to the 4th y, plus 9x to the 6th y divided by 9x to the 4th y, minus 9x to the 4th y over 9x to the 4th y. So I'm dividing that out of each term. And multiplying and dividing, so really I'm not changing anything here, but the result will be what? X to the 7th divided by x to the 4th is x to the 3rd power. X to the 6th divided by x to the 4th is x squared. Oh, I forgot my z in the last one, didn't I? Nines divide out. X to the 4th divide out. The y's divide out, leaving just a z. So we have 9x to the 4th y on the outside, 3x cubed plus x squared minus z. So any questions about that?
No.
Okay, good. Page 4. Factoring by grouping method. Factoring a 4-term polynomial. And this works, you have to have 4 terms. Arrange the terms so that the first 2 terms have a common factor and the last 2 terms have a common factor. For each pair of terms, use the distributive property factor out the pair's greatest common factor. If there's now a common binomial factor, factor it out. If there's no common binomial factor in step 3, begin again rearranging the terms differently. So out of the first pair, let's just take it how it is. The first pair, I can pull an x out, and we have a minus 2b. Now the second pair, watch this, I have this negative here. So if I, maybe I should back up. I'm going to back up and restart, because I want to do this in more steps. I'm going to rewrite the whole thing. It's ax minus 2bx minus 2ay plus 4by. So if I group them together, here's how I'm going to group them together. Put parentheses around them like that. And now if I group the second pair together, what happens to the term, or the symbol between the 2ay and the 4by? What's going to happen to that symbol? Yeah, it becomes a negative. Very good. Because you distribute this negative. Negative of the negative makes it positive. That double negative makes it positive. Okay, good. Very good. So we'd have, out of the first pair, what did I say, ax? No, just x. Then we'd have a minus 2b. What can we take out of the second pair? 2y. Good. A minus 2b. Now, notice we have a repeated factor. A minus 2b, a minus 2b. So we can factor that out now. A minus 2b. If that's out, what's left? X minus 2y. Okay, so it's a minus 2b times x minus 2y. Any questions about that? Let's try the next pair then. I'm going to leave it like it is and see if this works. But I see these 3xy and 3y, they have a lot in common. I'm tempted to just make those be a grouping, but I'm going to leave it like it is and see what happens. So if I group the first 2 together and the second 2 together, I can get x out of the first pair, x plus 3y. Out of the second pair, I can just pull a 1 out. Now 3y plus x is the same thing as x plus 3y. So this one isn't as fun. It's not as rewarding. You don't get to do as much with it, but that's it. X plus 3y times x plus 1. Order doesn't matter in addition. 3y plus x the same as x plus 3y. It would matter if it's subtraction. That'd make a big difference, but the addition doesn't matter. Let's just try doing that one more time. What if we rearranged x squared plus x plus 3xy plus 3y? See if we get a different answer. What can you take out of the first pair? We have x squared plus x. X, so it's x plus 1. Out of the second pair, what can we take out?
3y.
Good, 3y. Then we have x plus 1. So x plus 1 times x plus 3y. Get the same answer. And Elena, welcome. I saw you came in there. So that is factoring by grouping. We're ready to go on to the next thing. Factoring special binomials method. Okay. So factoring special binomials, we have really three things. A squared minus b squared. Good. A squared minus b squared is a minus b times a plus b. And difference of two cubes, a cubed minus b cubed. So this is different than we saw earlier. Each term is cubed, a cubed minus b cubed. And notice how it factors. This is different than what we saw earlier because it's a completely different problem. A minus b times a squared plus ab plus b squared. That looks like a perfect square trinomial, but is not a perfect square trinomial because there's no 2 with that ab. A cubed plus b cubed is a plus b times a squared minus ab plus b squared. Now, I want you to notice in each of these last two, there's only one negative. For a cubed minus b cubed, the negative is between a and b. For a cubed plus b cubed, the negative is between a squared and minus ab. So there's only one negative. Other than that, they look identical, just the negatives in different places. And we cannot factor a squared plus b squared. So here we have 27 a to the 9th plus b, 8b to the 12th. So obviously we can't factor it as a sum of cubes or sum of squares, but is it a sum of cubes? Can we think of this as a sum of cubes? Well, 27 is 3 cubed. A to the 9th, you can think of it as a cubed cubed. 8 is 2 cubed, and b to the 12th is b to the 4th cubed. So you really can think of this as 3a cubed cubed. That's our first term cubed, plus 2b to the 4th quantity cubed. That's how we can think of it. So what we saw earlier in the previous page, capital A would be the 3a cubed. Capital B would be 2b to the 4th. So how this breaks down is the following. 3a cubed plus 2b to the 4th. So that's like our a plus b. The second part was a squared minus ab, capital, I'm doing capitals versus lowercase, plus b squared. So what's that going to be? Our first term is 3a cubed, gets to be squared, minus 3a cubed times 2b to the 4th, plus 2b to the 4th squared. So I'm putting these things in those places, kind of like placeholders. I'm putting them in there, and then we're going to evaluate that. In the first part, 3a cubed plus 2b to the 4th, that's not going to change. We're done with that. We can do some stuff with the rest of this. 3a cubed squared. Well, 3 squared is 9. A cubed squared is a to the 6th. 3 times 2 is 6. A cubed b to the 4th. 2 squared is 4. B to the 8th. And that's it. So that might be one of the ones we're less familiar with. I know that I cover it in 096. The other teachers do as well, but it's typically one of the ones that are harder for people to kind of. And I won't say it's used all that often, but it's good to know how to do this. So again, I broke it down and looked at the first term as being something cubed, and the second term as something cubed. And then I applied that sum of cubes formula, and then plugged these parts into the different places. Any questions about that? Okay, go ahead, Joy. Yeah, so sum of difference of cubes is not going to be the same thing as a difference cubed. Completely different factoring. I mean, a difference cubed is going to have the 4 terms, and you factor that down to be a minus b quantity cubed. So they're 2 different things. So a minus b cubed is a cubed. It's minus 3a squared b plus 3ab squared minus b cubed. Correct. A minus b quantity cubed is not equal to a cubed minus b cubed. Correct. No relationship there. Are we good there? Correct. A minus b cubed is a minus b times a minus b times a minus b. That is correct. And what Elena, what Joy was referencing was earlier in the notes, I think it was page 3, we talked about a minus b quantity cubed and a plus b quantity cubed, but these are not the same thing as a cubed minus b cubed and a cubed plus b cubed. Okay, any other questions there before we go on? What's this next one going to be?
Is that the difference of 2 squares?
Very good, difference of 2 squares. Difference of squares. So you can think of this as 5x squared minus 4y quantity squared there. And the formula would be 5x plus 4y times 5x minus 4y. Okay. Factoring trinomials now. Let's talk about this. Factoring trinomials. Now, if your leading coefficient's 1, trinomials in the form x squared plus bx plus c, so leading coefficient's 1. Must find two numbers p and q such that p plus q is b and p times q is c. Now, there's another way to look at the same thing called diamond problems. You put your c up on top, your b down below. Look for two numbers that add up to be b and multiply to be c. If you call that p and q, it's x plus p times x plus q. So for example 6, the 9 on top, 6 down below. What numbers add to be 6 and multiply to be 9? Three and 3. So it's x plus 3 times x plus 3, which is x plus 3 quantity squared. Okay, what numbers add up to be multiply 6 and add to be negative 5? Now notice they add to be something negative and multiply to be something positive. Go ahead. Sorry, I didn't mean to talk over you.
Is it -2, -3?
Good job. -2, -3. So negative times a negative is a positive. And Callie has down there 2x minus 3 times x minus 2. Next one, we have a 4 up on top, a 5 down below. That's interesting. What numbers would multiply to be 4 but add to be 5?
1 and 4.
1 and 4. X plus 1 times x plus 4. Very good. Any questions before we go to the next page?
No.
Okay, now let's talk about factoring trinomials. I should say leading coefficient is not 1. It's ax squared plus bx plus c. You have a leading coefficient that's not 1. Here you're going to do something. What you're in essence, you're going to make it 4 terms and then factor by grouping. That's what's really happening here. How do you make it 4 terms? Well, this is how you do it. You take your leading coefficient a and your constant c, multiply them together, a times c. Factor a, c into 2 integers whose sum is b, so that think of m plus n as b, but m times n is ac. If no such factor exists, the trinomial is prime. Rewrite b in the trinomial with the sum found in step 2 and distribute. So in essence, we have ax squared plus bx plus c becomes ax squared plus m plus nx, because m plus n is b plus c. So ax squared plus mx plus nx plus c is what we have. 4 terms now factored by grouping. Let's do a few of these. That'll help make it more concrete. Okay, so we have 5 times negative 20 is negative 120. So we need to look for factors of negative 120 to add to be negative 37. What are factors of negative 120 to add to be negative 37? And what jumps out for me for 120, I think of like 4 and 3. And what would be negative 40 and positive 3 would do it. So this can be rewritten as 5a squared minus 40a plus 3a minus 24. And when I'm doing these, if I have a positive and negative, I put the negative one first, so I don't have to worry about, when I do go to parentheses, I have to change the other symbol. Now, if it does work out that you find a pair of numbers that multiply to be AC and add to be B, it's going to be factorable. So 5a squared minus 40a, what can you pull out of those two?
5a.
5a. Thank you. And then we'd have a minus 8. How about the second pair? 3a minus 24.
Just the 3.
A minus 8. So it's going to be 5a plus 3 times a minus 8. Any questions there?
No.
Oh, you're welcome. We're almost finished this too. So I'm going to do 1.4 tomorrow, by the way. I think at 9:30 I'll do 1.4. Ooh, wait, 9 o'clock. I'll do 9 o'clock tomorrow. 1.4. And for anyone who wanted to come to Fallon, I do teach these in room 206, but tomorrow I'm going to be doing 1.4 from home. What's your question, Kelly? You turn in all the homework as a bundle when the exam happens. So for exam 1, you're going to turn in chapters 1 and 2 as a complete bundle. You can email it. You can send it by U.S. mail. You can take it to your nearest campus and have it inter-campus mail. But my campus is Fallon. So you too. Okay, for the next one, we have 5x squared plus 27x minus 18. Do 5 times negative 18 is negative 90. So what are some factors of negative 90 that add to be 27?
Is that 3 and 30?
So how about 30 and negative 3? 5x squared, negative 3x plus 30x minus 18. I'll write this a second time so people who have seen this in the notes, they can see how it builds up there. The second pair, we could pull a 6 out. We have a 5x minus 3. It's 5x minus 3 times x plus 6. Any questions there?
No.
Elena, any questions? Okay. Moving on down, factoring expressions containing fractional exponents. So identify the least exponent among the various terms. Factor the variable raised to the least exponent from each of the terms, then factor out any other common factors. Simplify if possible. So here we have 2x to the negative 2 plus 3x to the negative 1. So what I would do, I'm going to factor out the x to the negative 2. Factor, not facts. Factor out x to the negative 2. So it's going to be x to the negative 2 times 2x to the negative 2 divided by x to the negative 2 plus 3x to the negative 1 divided by x to the negative 2. I'm dividing that out of each term. So x to the 2 divided by x to the 2, that's just 1. X to the negative 1 divided by x to the negative 2 is x. So it's x to the negative 2 times 2 plus 3x. So if I multiply this back through, x to the negative 2 times 2 is 2x to the negative 2. X to the negative 2 times 3x to the positive 1 is 3x to the negative 1. Any questions there?
No.
Okay. Now notice this one, we have these fractional powers here as well. What is the smaller power?
The 2/3.
2/3, yeah. So think of this as 3z plus 2 to the 2/3 is going to be on the outside. 3z plus 2 to the 5/3 divided by 3z plus 2 to the 2/3. I'm factoring that out. Minus 3z plus 2 to the 2/3 over 3z plus 2 to the 2/3. I'm going to write this one more time, just because there's a lot of stuff here that can get jumbled if I start crossing out. 3z plus 2 to the 5/3 over 3z plus 2 to the 2/3. 3z plus 2 to the 2/3 over 3z plus 2 to the 2/3. So in the first, 3z plus 2 to the 5/3, 3z plus 2 to the 2/3. Think of this as 5/3 minus 2/3 is 3/3, which is 1. And then 3z plus 2 to the 2/3, 3z plus 2 to the 2/3, that's just going to give us 1. So our result is going to be 3z plus 2 to the 2/3 gets factored out, and what's left inside? 3z plus 2 to the 1 power minus 1. Now I could take this a little further, and I will. A little bit. I mean, not much to do here, but a little bit. That's 3z plus 2, because 3z plus 2 to the 1 is 3z plus 2 minus 1. 3z plus 2 to the 2/3, 3z plus 1. So there's our final result. So again, we pulled out the lowest fractional, the term with the fractional exponent. And then it worked out kind of nice. We were able to knock that down a little bit. Any questions about that? Is that a no?
Yeah, that was enough.
Okay. Okay. Well, that's the end of this section. Again, we don't have time to do the other section in 10 minutes, so we will do 1.4 tomorrow. My plan is 9 o'clock. 9 a.m. If anything changes, I will email you. I do have to be in Carson tomorrow morning at 10:30, so that's why I have to do this. I was planning on doing it at 9:30, but I have to be in Carson. So if something changes, I will let you know. If anything changed, it may go to, it would be that I push it back to 9:30. But okay, that's it for today then. And I will see you tomorrow if you can make it tomorrow. Oh, I see Joy's coming in. I hate to. Sure, I'm going to end the archive at least, but I want to say hi to Joy again. So I'll end the archive in 5, 4, 3, 2, 1.